Okay guys, I'm going to do a real quick video and we're going to talk about the types of projectiles. Now, as we can see, we have our first one here, and it's debatable whether this one's a projectile, but here we have a a student, and maybe he's like dropping a rock from a cliff, and as we can see, guys, the displacement is going to keep increasing in a negative manner. So like this right here is the y-axis, and in fact, if we call this point right where he drops it at, say that this point right here, that is 0, comma 0. I'm pointing at this point right here. There we go, we ran the line. That's 0, comma 0. That everything down here is going to be the negative direction on the y-axis, and it's going to increase greater and greater. Other things that happen with this one to be sure of is that we should see that our velocity is getting larger and larger. As this object falls, starts off with a small velocity, gets bigger, bigger, and bigger. Control Z. Oh, stop. Control Z. Now, what we'll see here is another object, and this object goes up and starts off with a positive velocity, but that velocity gets smaller and smaller until it stops. Up here, guys, very important, at the very top of this, your velocity in the y direction is 0 meters per second at the top. And the funny thing also, guys, for this one, right here, in the velocity in the y direction is also 0 meters per second. At maximum height, this is a characteristic. It's always going to be 0 meters per second at the maximum height. We'll talk more about this one in a little bit. We'll maybe illustrate this picture a little better, but it's very important to realize that as this thing goes up, it's going to slow down in the y direction, but it should have a constant velocity in the x. Okay. And a projectile is an object which the only force is gravity. Great. Now, that's the simplified definition for us. Remember, guys, we are often going to forget or neglect air resistance. Yikes, I think it's, there we go, resistance. Okay, let's go down further. So let's say if we shot a cannon, this is the inertial or gravitational free path. And what we'll see, guys, is that this ball just wants to go in a straight line. Everything just wants to go in a straight line at a constant velocity. But we know that this is not going to happen in the real world. This is in the absence of gravity. An object in motion will continue in motion in the same speed in the same direction. That's the law of inertia. That's what things want to do. But we'll get down here, and we'll actually see that we have this parabolic trajectory. And that's what actually happens. So with gravity, a projectile will fall below its inertial path. Gravity acts downwards to cause a downward acceleration. There is no horizontal force needed to maintain the horizontal motion consistent with the concept of inertia. So guys, once again, this thing is going to keep going in the x direction at a constant rate because of inertia, because it's at equilibrium in the x direction. So the y direction, there won't be equilibrium, so it will, in fact, curve downward. But this is very cool to think about it in terms of inertia. And as if we look, guys, we can think of all of our projectiles in two axes. So gravity accelerates downward, but is unable to affect the horizontal motion of the projectile. And so we'll see that we can look and watch the projectile move this way, and watch what would happen if the object was just dropped. These are two hypotheticals. This is the inertial path, and this is a free fall path. And if you see, if we map these two together, we'll get the actual projectile motion. And I think that's a very cool thing to think of. If you map this trajectory two different ways, once with just the inertial gravitational free path, and once with just gravity, you'll actually get the map of the projectile. Okay, awesome. And we can see this, guys. This is a cool drawing right here to make it into your notes of some sort, to be noted, that you'll notice that if in the x direction it has constant velocity, but it starts off with no y, and for every second of flight, this is going to increase. And you should notice that this is a familiar value. It's missing the 0.01 that we have, but this is a very cool picture, guys, and definitely of importance. Now here's another one. Here's what an object going up has. Now notice it has an initial positive velocity, but over time that positive velocity decreases to 0. Take a look right here. Here is our max height. And here we go. And notice, guys, right here, when we get to the max height, we can treat the y values as just free fall, and the x values stay constant. Something very interesting to think of. I really want to thank, guys, the Physics Classroom. It's a great website, and it's where I stole these pictures from. Okay, so thank you, Physics Classroom. Thanks, guys, for listening.